The fire had burned all night, filling the main room with warmth, but Annalise Thorne died anyway, frozen in her bed just 20 feet from the flames. What Casper built in the months that followed would change how every settler in the Wyoming Territory understood heat, survival, and the fatal flaw in every cabin they had ever constructed. Before we begin, let us know where you're watching from. And if frontier innovation stories like this resonate with you, subscribe now because tomorrow's episode reveals an invention even more unexpected than this one. Casper Thorne woke on the morning of February 14, 1841, to a silence that felt wrong. The fire in the main room had burned through the night. He could see the orange glow from where he lay, could feel warmth radiating from the stone fireplace 20 feet away. But the blankets beside him held no warmth at all. Annalise was gone, and when he touched her shoulder to wake her, her skin was cold as winter stone. The bedroom occupied the back corner of their cabin, separated from the main living area by a single timber wall with a doorway cut through it. Standard construction for Wyoming Territory settlers. One large room for cooking, eating, and daily living. One smaller room for sleeping. A fireplace built into the corner of the main room, its chimney rising straight through the roof and extending 6 feet above the ridgeline. Casper had built it himself 3 years earlier, following the same pattern every other settler used. It had seemed adequate then. He carried Annalise's body into the main room and laid her near the fire. The warmth there was substantial, 70 degrees at least, maybe warmer. He had been comfortable all night, sleeping in his usual wool nightshirt, never cold enough to wake. But Annalise had gone to bed feeling poorly, complaining of chills. She had piled on extra blankets. It hadn't been enough. Casper walked back into the bedroom and stood in the doorway. He could feel the temperature difference immediately. The bedroom was brutally cold. His breath made clouds in the air. He guessed 35 degrees, maybe colder. The wall between the rooms wasn't insulated. The doorway allowed some air circulation, but clearly almost none of the fire's heat reached this space. 20 feet. That was all the distance between the roaring fire and where his wife had frozen to death. He spent the rest of that day in a fog of grief and disbelief. Neighbors came. Matthias Keller helped him build a coffin. Cyrus Ashford and his wife brought food. Everyone offered condolences. Several mentioned that winter deaths were common, that sickness combined with cold took many lives, that Annalise had been frail. Casper said nothing. He knew what had killed her. It wasn't sickness. It was cold. Cold that shouldn't have existed 20 feet from a fire that burned all night. They buried Annalise 3 days later on a hillside overlooking the creek. The ground was frozen. It took Casper and 4 other men most of a day to dig through the iron-hard earth. He marked her grave with stones and returned to his cabin alone. That night, he built up his fire until the main room was almost uncomfortably warm. Then he walked into the bedroom with a candle and stood in the freezing air, watching his breath cloud in the darkness. The wall between the rooms might as well have been a wall between summer and winter. Heat simply didn't cross it. Casper had been a carpenter before moving west. He understood how buildings worked, how materials behaved, how structures succeeded or failed. But in that moment, standing in his frozen bedroom with a raging fire 20 feet away, he realized he understood nothing about heat, and that ignorance had killed his wife. Casper spent the week after Annalise's funeral conducting an experiment that his neighbors found peculiar. He visited every cabin within a day's ride of his homestead, carrying a small leather satchel that contained a thermometer he had purchased in St. Louis 2 years earlier. The instrument was delicate, expensive, and had seemed like an indulgence when he bought it. Now it became the tool that would change everything. He started with Cyrus Ashford's cabin, arriving unannounced on a cold morning in late February. Cyrus was cooking breakfast when Casper entered. The main room was warm, comfortable. Casper placed his thermometer on the table near the fireplace and waited 5 minutes. 68 degrees. Then he asked permission to check the sleeping area. Cyrus looked confused but agreed. Caspar walked into the back bedroom, placed the thermometer on a chair, and waited. 32 degrees, exactly freezing. He visited Matthias Keller next. Same pattern. Main room warm, bedroom frozen. Then the Johnsons, the Pratts, the Blackwells. Every single-story cabin showed identical results. Temperature differences of 30 to 40 degrees between the room with the fireplace and spaces just one wall away. The families living in these cabins had adapted without realizing it. They slept in heavy clothes under multiple blankets. They kept children in the main room during the coldest nights. They accepted frozen bedrooms as simply how cabins worked in winter. Caspar asked questions everywhere he went. Had anyone tried to solve this problem? A few had attempted solutions. The Pratts had cut a second doorway between rooms, hoping air would circulate better. It helped marginally. The Blackwells had built a second, smaller fireplace in their bedroom. It worked, but required twice the firewood and constant attention to 2 fires. Most people just accepted the cold. What fascinated Caspar was how quickly heat disappeared. He stood outside Cyrus Ashford's cabin one afternoon and watched the chimney. Smoke poured out constantly, a thick column rising into the winter sky. He could feel heat radiating from the stone chimney where it emerged from the roof. All that warmth, generated by burning valuable firewood, was escaping into the air within seconds of being created. The fireplace heated the immediate area around it. Then the chimney carried everything else straight up and out of the cabin. The design was fundamentally wasteful. Heat rose naturally. The chimney exploited this principle to remove smoke, but in doing so, it also removed most of the warmth the fire created. By the time hot air from the fireplace could spread through the cabin, reaching distant rooms, it had already been sucked up the chimney and vented outside. The cabin wasn't heated. Only the space directly around the fireplace received any benefit. Caspar returned home in early March with his notebooks full of measurements and observations. Every cabin suffered the same flaw. Heat escaped before it could distribute. The solution everyone used, building hotter fires and burning more wood, just sent more warmth up the chimney. It was like trying to fill a bucket with a hole in the bottom by pouring faster. Caspar became obsessed with smoke. He spent hours sitting outside his cabin, watching the column rise from his chimney. On calm days, it ascended straight up, disappearing into the sky. On windy days, it bent and dispersed, but always upward, always carrying heat away from where it was needed. He timed how long smoke took to travel from fireplace to open air. Less than 3 seconds in his cabin, 3 seconds from flame to frozen sky. He started asking questions that made his neighbors uncomfortable. Why did chimneys have to be built that way? Why straight up? Why outside the living space? Most men looked at him like he was mad. Chimneys went up because smoke rose. They were built tall to create draft and prevent smoke from entering the cabin. This was basic knowledge, settled practice, not worth questioning. But Matthias Keller had different knowledge. He was a German immigrant who had arrived in Wyoming Territory 5 years earlier. One evening in late March, Caspar asked him about heating methods in the old country. Matthias described something called a Grundofen, a masonry stove his grandfather had built in their home near Munich. The structure was massive, taking up nearly a quarter of the main room, but it heated the entire house with a fraction of the wood a standard fireplace required. The secret, Matthias explained, was internal channels. The fire burned in a small firebox, but the smoke didn't go straight up and out. Instead, it traveled through a maze of passages built inside the masonry structure. The smoke wound back and forth, up and down, through perhaps 20 feet of stone channels before finally exiting through a chimney. All that travel time allowed the stone to absorb the heat. The masonry mass would stay warm for 10 to 12 hours after the fire died, radiating heat constantly. Caspar made Matthias repeat the description 3 times. He drew diagrams in his notebook. The concept seemed to violate common sense. Everyone knew smoke needed to escape. quickly, but Matthias insisted it worked. His grandfather's house had been the warmest in the village, heated by one fire per day, while neighbors burned wood constantly. The critical insight came to Caspar a week later. The problem wasn't fire. Fire created plenty of heat. The problem was capture. Standard chimneys let heat escape before the cabin could absorb it. What if the chimney itself became part of the cabin's interior? What if smoke traveled through the living space before exiting, giving up its warmth along the way? He began sketching designs. A fireplace in the corner, the flue rising a few feet, then turning horizontal, running through the main room at ceiling height, passing through the wall into the bedroom, continuing through that space, finally exiting at the far end of the cabin, elevated enough above the fireplace to maintain draft. The entire chimney path would be inside, built from stone or clay that would absorb and radiate heat. It was unconventional. It violated every rule of frontier construction, but physics suggested it should work. Spring arrived in early April, 1841. Snow melted from the hillsides, creeks swelled with runoff, and settlers began preparing for the season's work. Caspar Thorne announced his intention to tear down his existing chimney and rebuild it using a horizontal design. The reaction from his neighbors ranged from confusion to outright mockery. Cyrus Ashford was the most vocal critic. He arrived at Caspar's cabin 3 days after hearing the plan, bringing 2 other settlers with him. They found Caspar sketching measurements on his cabin wall with charcoal, marking where the new flue path would run. Cyrus studied the marks for a long moment before speaking. "Smoke goes up, not sideways. You're wasting your time and risking your life." Caspar explained his reasoning. The current chimney vented heat within seconds. A horizontal path would keep that heat inside, warming the entire cabin instead of the sky. The stone flue would absorb warmth and radiate it for hours. One fire could heat every room instead of just one corner. Cyrus shook his head. "Draft requires vertical rise. Your horizontal sections will fill the cabin with smoke. You'll suffocate before autumn." Others joined the criticism over the following weeks. Barnabas Keene called it dangerous. Running a hot chimney through wooden roof structures was asking for fire. Matthias Keller, despite having described his grandfather's masonry stove, expressed doubt about adapting the concept to a frontier cabin. The Grundofen had been built by skilled masons using specific materials. Caspar was a carpenter working with frontier resources. The margin for error was thin. The strongest objection came from simple tradition. Chimneys had been built the same way for generations. Vertical, exterior or barely interior, venting smoke as quickly as possible. Changing that pattern seemed like rejecting accumulated wisdom. Several neighbors suggested Caspar was still grief-stricken, not thinking clearly, making decisions based on emotion rather than sense. Caspar listened to every objection. He acknowledged the risks. Fire danger was real. Smoke problems were possible. The design might fail completely. But he also knew that traditional chimneys had a fatal flaw. Annalise had frozen 20 feet from a fire that burned all night. That fact outweighed every argument about proper construction methods. He began work in May. The first step was removing his existing chimney above the roof line. He salvaged every usable stone, stacking them near the cabin. The work was slow and careful. He couldn't afford to damage the roof structure or waste materials. Each stone had to be cleaned of old mortar and sorted by size and shape. By June, he had dismantled everything above the main room ceiling. The fireplace remained functional for cooking, venting through a temporary opening. But the real construction was about to begin. Caspar had spent the spring collecting additional materials. Clay from the creek bank, sand for mortar, small flat stones for the interior flue lining. He had purchased lime from a trader passing through, expensive but necessary for proper mortar. Everything was ready. Cyrus Ashford stopped by one evening and watched Caspar working. "You're really doing this?" Caspar nodded. Cyrus shook his head and walked away. Casper began construction in early June 1841. The design he had refined over months of planning required precision that frontier building rarely demanded. He started by reinforcing the cabin's roof structure. The horizontal chimney would add significant weight to areas never intended to bear such loads. He installed additional support beams, thick timbers cut from pine trees he had felled specifically for this purpose. Each beam was positioned to carry weight from the stone flue above down to the cabin's log walls. The fireplace location was critical. Most cabins had fireplaces built into exterior walls for easier chimney construction. Casper's fireplace sat in the southeast corner of the main room, positioned so the flue could travel the maximum distance through interior space before exiting. He rebuilt the firebox using firebrick he had traded for at considerable expense. The firebox was deeper than standard designs, angled to direct flames upward into the flue throat with maximum efficiency. The flue began with a vertical section rising 4 feet above the firebox. This height was calculated carefully. Too short and draft would be weak. Too tall and he would waste interior space that could be radiating heat. 4 feet provided enough initial rise to establish strong updraft while keeping most of the chimney's length horizontal. At the 4-foot mark, the flue turned 90 degrees, becoming horizontal and running south to north through the main room at ceiling height. Construction of the horizontal section required techniques Casper had never attempted. The flue channel itself was rectangular, 10 inches wide and 12 inches tall. He built it using a double-wall method. The inner layer consisted of small, flat stones fitted tightly together and mortared with lime mixture. This surface would contact hot smoke directly and needed to withstand extreme temperatures. The outer layer used larger stones, creating a thick wall that would absorb and store heat. Between the inner and outer layers, Casper packed clay mixed with sand. This layer served multiple purposes. It insulated the hot inner flue from the wooden roof structure above. It added thermal mass for heat storage, and it allowed for slight expansion and contraction as the chimney heated and cooled. The total thickness of the horizontal flue was 18 inches from inner channel to outer surface. Supporting this mass required careful engineering. Casper built stone piers at 8-foot intervals, rising from the cabin floor to support the horizontal flue sections. Each pier was 2 feet square at the base, tapering slightly as it rose. The piers didn't just support weight. They also acted as additional thermal mass, absorbing heat from the flue above and radiating it into the room. The flue traveled 14 feet through the main room before reaching the interior wall that separated living space from bedroom. Casper had to partially dismantle this wall to pass the flue through. He created an opening 2 feet square, lined with stone, through which the chimney continued into the bedroom space. The opening was sealed around the flue with clay and mortar, preventing smoke leakage while allowing the stone chimney to radiate heat into both rooms. In the bedroom, the flue continued another 12 feet, supported by 2 more stone piers. The path angled slightly upward, rising 6 inches over its horizontal run. This gradual incline was essential for maintaining draft. The first major problem revealed itself in early July. Casper had completed the horizontal section through the bedroom and begun constructing the vertical exit chimney at the cabin's north end. When he lit a test fire to check the draft, smoke filled the bedroom within minutes. The flue wasn't drawing. Hot gases accumulated in the horizontal sections instead of traveling through to the exit. He had built an elaborate smoke trap. Casper spent 2 days studying the failure. The issue was air pressure and flow dynamics. The horizontal sections created resistance that his modest vertical rise couldn't overcome. He had calculated 4 feet of initial rise plus the gradual 6-inch incline through the horizontal run, totaling roughly 5 feet of elevation gain. It wasn't enough. He needed more vertical distance between the firebox and the final exit point. His solution required raising the exit chimney. He added another 4 feet to the vertical section at the north end of the cabin, bringing the total elevation gain to 9 feet from firebox to chimney top. The additional height increased draft significantly. On the next test, smoke began drawing properly, though slowly at first. As the flue warmed, draft improved. Within 20 minutes, the system was pulling smoke efficiently through the entire horizontal path. The second problem was creosote accumulation. Creosote formed when smoke cooled inside the chimney, depositing sticky, flammable residue on flue walls. Vertical chimneys managed this by maintaining high temperatures and allowing creosote to burn off periodically. Horizontal sections allowed smoke to cool more, creating heavier deposits. Casper recognized this would become dangerous if not addressed. He designed cleaning access points at 3 locations along the horizontal run. Each access consisted of a removable stone section fitted precisely into the outer chimney wall. The stones could be taken out, allowing Casper to reach inside and scrape creosote from the flue channel. He sealed the access points with clay mixed with ash, creating a temporary seal that could be broken and remade as needed. The system was crude but functional. Weight distribution presented the third challenge. The horizontal chimney, built from stone and clay, weighed nearly 2 tons. Casper's support piers carried most of this load down to the cabin floor, but the roof structure still bore significant stress where the chimney passed through. He noticed slight sagging in the roof beams by mid-July. The problem wasn't critical yet, but it would worsen over time. He reinforced the affected areas by installing diagonal bracing between the roof beams and the top logs of the cabin walls. The bracing transferred weight away from the weakest points and distributed it across multiple structural elements. He also added external buttressing, angled timbers running from the ground to the roof edge at points where the interior chimney created maximum load. The buttresses were visible from outside, making the cabin look even more peculiar to passing neighbors. Fire danger consumed much of Casper's attention during construction. The horizontal flue ran directly beneath wooden roof planks in several sections. Despite the clay insulation layer, the outer surface of the chimney reached temperatures that could ignite dry wood over time. Casper created an air gap between the chimney's top surface and the roof planks, using stone spacers to maintain a consistent 2-inch separation. Casper completed construction on October 3, 1841. The project had consumed 5 months, longer than building an entire cabin from scratch. The horizontal chimney stretched 38 feet from firebox to exit, with 26 feet running through interior space. The structure weighed approximately 2,300 pounds. Every neighbor who saw it predicted failure. He lit the first full fire on a cold morning in mid-October. The process required careful attention. He started with kindling only, creating a small flame to begin warming the flue, cold stone, and clay. Needed gradual heating to prevent cracking from thermal shock. He fed the fire slowly, adding larger pieces of wood as temperatures rose. Smoke behaved erratically at first, puffing back into the room before being drawn up and through the horizontal sections. The problem was airflow. Cold air filled the long horizontal flue, creating resistance. Until the entire chimney warmed, draft remained weak. Casper kept the fire small and steady, waiting. After 40 minutes, something shifted. The flue began drawing strongly. Smoke disappeared cleanly into the firebox throat. He could hear the quiet roar of air being pulled through the system. The chimney had come alive. He spent the rest of that day monitoring temperatures and behavior. The stone piers supporting the horizontal sections grew warm to the touch within 2 hours. By afternoon, they radiated noticeable heat. The bedroom, which had always been freezing, felt comfortable for the first time since Annalise died. Casper walked from room to room, holding his hand near walls and ceiling. Heat was everywhere. By evening, he made a discovery that changed everything. He let the fire die down to coals, then stopped feeding it entirely. In a normal cabin, this would mean rapid cooling. The main room would stay warm briefly, but distant rooms would turn cold within an hour. Casper's cabin behaved differently. The massive stone chimney had absorbed heat all day. Now it released that stored warmth gradually. Hours after the fire died completely, the bedroom remained comfortable. The main room stayed warm. The entire cabin held temperature. He slept in the bedroom that night for the first time since February. The room that had killed Annalise now felt safe. He woke twice to check temperatures with his thermometer. At midnight, 6 hours after the fire had gone out, the bedroom registered 58 degrees. At dawn, the temperature had dropped to 52. Cold, but survivable. Not the killing cold that standard cabins produced. Casper relit the fire the next morning and began testing systematically. He measured how long fires needed to burn, how much wood was required, how temperatures distributed through different rooms. The results were remarkable. He used roughly the same amount of firewood as before, but instead of heating one corner, he heated 2 full rooms. The thermal mass effect meant he could burn fires for shorter periods and still maintain comfort for extended time afterward. Cyrus Ashford visited in late October. He stood in the bedroom feeling the warmth and said nothing for a long time. Winter arrived in November 1841. Casper refined his heating routine as temperatures dropped. He discovered the system worked best with 2 fires daily. A morning fire burned for 3 hours while he completed chores and prepared food. The chimney absorbed heat during this period, warming thoroughly. An evening fire burned for 2 hours before bed. Between fires, the thermal mass sustained. Comfortable temperatures for 8 to 10 hours. The efficiency surprised him. He had expected to use the same amount of firewood as previous winters. Instead, he burned roughly 30% less. The long horizontal flue extracted heat that vertical chimneys wasted. Every degree of warmth the smoke carried went into stone and clay instead of into the sky. The massive thermal battery charged during burning and discharged slowly when the fire died. Temperature distribution became predictable. During active burning, the main room reached 70 degrees near the fireplace, 65 degrees at the far end. The bedroom, once frozen, maintained 60 to 62 degrees. After the fire died, temperatures dropped gradually. The bedroom would reach 55 degrees by morning, cold but manageable with blankets. More importantly, not lethal. Casper documented everything in his notebook: wood consumption per fire, burn times, temperature measurements taken at different locations and times. He tracked outdoor temperatures and compared them to interior readings. Patterns emerged. When exterior temperatures dropped below 0, interior temperatures never fell below 50 degrees if he maintained his twice-daily fire schedule. The cabin had become genuinely weatherproof. Neighbors began asking questions. Matthias Keller visited in December and spent an afternoon examining the system. He touched the stone piers, feeling residual warmth hours after the fire had died. He stood in the bedroom, comparing its temperature to memories of his own frozen sleeping quarters. The skepticism he had shown during construction softened. This works better than I expected. Cyrus Ashford remained publicly dismissive but stopped making jokes. His own cabin required constant fire tending to keep even the main room comfortable. He burned twice the wood Casper used and still woke to frozen bedrooms. The contrast was becoming obvious. Other settlers noticed. Barnabas Keene asked detailed questions about construction techniques. How thick were the flue walls? What mortar mixture worked best? How much did the materials cost? Casper shared information freely. He showed visitors the access points for cleaning creosote. He explained the importance of gradual elevation gain for maintaining draft. He described the thermal mass principle, how stone absorbed and released heat over time. Some listened carefully. Others remained unconvinced. Wait for real cold, they said. Wait for January. January came. Temperatures plunged. On the 14th, Casper's outdoor thermometer read 38 degrees below 0. He maintained his normal fire routine, 2 burns daily. The cabin stayed livable. The bedroom never dropped below 48 degrees. He slept comfortably under 2 blankets instead of the 4 he had needed in previous winters. The system wasn't just working, it was exceeding every prediction he had made. Outside, the wind howled across frozen ground. Inside, stone radiated warmth into darkness. The blizzard arrived on January 22, 1842. It began as light snow in the morning, then intensified throughout the day. By evening, wind drove snow horizontally across the prairie. Visibility dropped to nothing. Temperature plunged to 43 degrees below zero, the coldest reading Casper had ever recorded. The storm continued for 3 days without break. Casper maintained his fire routine with minor adjustments. He extended burn time slightly, keeping fires active for 4 hours instead of 3. The extra heat proved unnecessary. The cabin stayed warm. Snow accumulated against the north wall, actually improving insulation. The horizontal chimney radiated steady warmth. He moved freely between rooms, never needing heavy clothing indoors. The bedroom remained above 55 degrees even at night. On the second day of the storm, he heard pounding on his door. He opened it to find Barnabas Keene standing in waist-deep snow, face wrapped in cloth against the wind. Barnabas stumbled inside, shaking with cold. His son was sick. The boy had developed a cough 2 days before the storm. Now he was worse, feverish, and struggling to breathe. Barnabas had come for help, fighting through the blizzard because he had nowhere else to turn. Casper gathered supplies, medicine, blankets, firewood. He followed Barnabas back through the storm to his cabin half a mile away. What he found there was familiar and terrible. The main room was warm, almost hot. Barnabas had been burning wood constantly, trying to heat the entire cabin, but the bedroom where his son lay was brutally cold. Casper's thermometer read 31 degrees. The boy, 9 years old, was wrapped in every blanket the family owned and still shivering violently. They moved the boy into the main room, placing him near the fire. Casper stayed through the night, helping Barnabas maintain the fire and care for the child. By morning, the fever had broken. The boy would survive. But the close call shook Barnabas deeply. He kept looking at his bedroom door, understanding fully what the temperature difference meant. If they had left the boy there another night, he might not have lived. When the storm finally broke on the 4th day, word spread quickly. Casper's cabin had stayed warm throughout. Barnabas Keene's son had nearly died from cold, despite a fire burning constantly. The contrast was stark and impossible to dismiss. Cyrus Ashford visited 2 days after the blizzard ended. He didn't announce his arrival or explain his purpose. He simply walked through Casper's cabin, examining the horizontal chimney from every angle. He touched the stone piers, still faintly warm. He stood in the bedroom, measuring the space with his eyes. "How long did it take you to build this?" 5 months, Casper answered. Cyrus nodded slowly. "I'll need help rebuilding mine. Can you show me how?" Casper agreed. By spring, he knew, others would ask the same question. The mockery was over. Necessity had settled the argument. Spring arrived in March 1842. Casper spent April and May helping Cyrus Ashford rebuild his chimney using the horizontal design. The work went faster with 2 men and the benefit of Casper's experience. Cyrus made modifications based on his cabin's layout, running the flue through 3 rooms instead of 2. The principle remained the same. Keep heat inside. Use thermal mass. Distribute warmth throughout the living space. Matthias Keller began his rebuild in June. Barnabas Keene started in July. By autumn, 6 families within a day's ride had adopted the technique. Each installation varied slightly based on cabin size and layout, but the core innovation spread consistently. Horizontal flues running through interior spaces, stone construction for thermal mass, gradual elevation changes to maintain draft. The results were uniform: warmer cabins, lower wood consumption, Elimination of frozen bedrooms. Word traveled through the scattered settlements of Wyoming Territory. Travelers passing through saw the unusual chimney designs and asked questions. Casper's name became attached to the technique, though he never promoted himself or claimed special credit. He simply helped anyone who asked, sharing measurements and methods freely. The innovation solved a real problem. That was enough. By 1845, the horizontal chimney design had become common enough that settlers building new cabins incorporated it from the start. The phrase "thorn-style chimney" appeared in conversations and letters. Builders began teaching the technique to newcomers. The method evolved as others added improvements. Some used brick instead of stone. Others developed better mortar formulas. A settler named Douglas Chen created a damper system that allowed more precise control of draft and heat retention. Casper watched the spread with quiet satisfaction. He had not set out to revolutionize frontier heating. He had simply wanted to solve the problem that killed Annalise. The fact that his solution helped others was meaningful, but he sought no recognition beyond seeing families survive winters that might have killed them otherwise. He continued living in his cabin until 1851, when he sold his land and moved to Oregon Territory. The new owners, a family named Morrison, maintained the horizontal chimney system and lived comfortably through 16 more winters. The cabin stood until 1873, when it was finally dismantled to make room for a larger house. The stones from Casper's chimney were salvaged and reused in the new structure's foundation. Casper Thorne died in 1868 at the age of 61 in Portland, Oregon. He had remarried, worked as a carpenter, and lived an unremarkable life. His obituary made no mention of his innovation or the lives it had saved. He was buried in a small cemetery outside the city. The grave marker bore his name and dates, nothing more, but across Wyoming Territory and beyond, cabins built with horizontal chimneys continued warming families through brutal winters. The technique persisted long after its creator was forgotten. The innovation had been carved not into history books, but into stone and clay, radiating warmth into the darkness, solving the simple problem of keeping people alive when winter came.